Out of a sample of 500 men's shirts, 17 were rejected because of crooked collars. How many crooked collars would you expect to find in a run of 15,000 shirts? To solve this problem, we're going to apply some knowledge to a small number of shirts, 500. Well, that's a lot of shirts for anyone's particular closet, but much less than the 15,000. Small number of shirts, we know 17 are rejected. We're going to apply knowledge for that small amount to the whole batch. So I'm going to look at a ratio of bad shirts to total shirts, at least on this small batch, 17 over 500. And we'll apply that knowledge to the 15,000 shirts. So this 17 over 500, if you want to think about it in terms of, say, percents or something, this is the percent of shirts that are defective, or defective because of crooked collars. So if I multiply this by the 15,000, that's going to tell me how many of these 15,000 are defective. Another way to think about this, mathematically, we just write it that way, but another way to think about this is I'm trying to figure out how many 500s there are in 15,000. And if I know how many 500s there are, I expect out of each 500, 17 to be rejected. So I'll multiply a number of 500s that I have by 17. How do I figure out how many 500s are in 15,000? I do 15,000 divided by 500. Right? And then I multiply by the 17, and that tells me that. So same computation I'm doing here. Take the ratio, 17 500s, times the total number of shirts. That should tell us what we'd like to know. To do this multiplication, why don't I make it a little bit easier? Right? Instead of 500, let me think about it as 5 times 100. Instead of 15,000, why don't I think about it as maybe 150 times 100, and then my 100s cancel. That's great. 5 goes into 150 some amount of times. If you're good at your factors, you know what that is. If you're not so good, well, that's okay. We'll break it up a little more. 150, that's 15 times 10. 10, that's 2 times 5. There's my 5. So that cancels with that 5, and I'm left with 2 times 15 times 17, which of course is another hard product to do. Let me write 15 as 3 times 5. So on one hand, you could leave this here. There's your final answer, a bunch of stuff multiplied together, right? If you really feel like multiplying it out, don't go ahead and do 2 times 15, 30, 30 times 17, and do that multiplication on the side of your page and whatever. I mean, I guess you could, but that takes a while. Maybe we'll be able to do it quickly when it's already in this prime factorization. After all, it's easy to multiply something by 2. It's pretty easy to multiply by 3. It's pretty easy to multiply by 5. So if I just slowly build things up with these easy multiplications, that's a bit easier than multiplying, 17 by 30. In my mind, it is, at least. So why don't we take, say, 17 and multiply it, by 3. Right? So that gives us, a 51. So we'd have a 51 times 2 times 5. Of course, 2 times 5, that's 10. 51 times 10, 510. So there's a easy way to do the product, at least easy in my mind. But if you don't feel like doing that, there is a correct answer, 2 times 17 times 3 times 5, right? Or there is a correct answer, 17 times 15 times 2. Right? It's not that helpful when you're talking to someone on the phone and they're saying, how many shirts are going to be bad and we need to make sales estimates. They want to know the 510, but once you're outside of the context of this class and you're allowed to use calculators again, you could do that product on a calculator, no problem. Right? So for purposes of tests or quizzes, unless you feel comfortable with your multiplication and it doesn't take you much time, don't do that way. That takes time. Leave your answer that way. All right. I'll stop blathering.